Okay, let's see what is binary search tree. First of all, we would learn about the meaning of key value pair and the search tree. Okay, first, what is key value pair? It actually contains two data items. One is called key, another one is called value. Okay, they appear as a pair. So in short, it is called KVP. The key, which is a unique identifier for some item of data. And you can imagine that the value, which is usually the data that is identified. That data. Or actually it is a pointer or an object reference in the term used in Java to the location of that data. So let's see some examples. Just like this one. Okay, 0, 1, 2. They are the keys. And apple, orange, pineapple are the value. Okay, it is easy for you to imagine. At the same time, this key may not be continuous, just like 002, 004, 007. Okay, they could also be the key. Okay, even though they are not just like the previous example, 0, 1 or 2, followed by 1. Another example is that, okay, here the key may not be a number at all, just like a dictionary. Okay, you would like to have the key as the text or string. Okay, they can also be the key. But in this case, okay, you can see that the Chinese translation in this case is the value. Okay, these are the values. So when we talk about the search tree, okay, it is a tree data structure that can be used to perform searching for key value pair. And the key is the one who is used to construct the tree structure. Okay, let's see the definition of the binary search tree after we have learned what is key value pair as well as a search tree. First, it will be a binary tree. As you should still remember that a binary tree should have the concept of left and right, and left child and the right child, left child and the right child. Okay, so each node has a key value pair. Okay, for example, in the previous example, okay, it should be something like 1 apple, here you have 2 orange, and so on. So for each node x, all the keys in the left subtree of x are smaller than the key in x. What's that mean? For example, it is x, the key is x. All the keys in the left must be smaller than that of the key in x. Must be smaller. And for every node x, all the keys in the right subtree of x are greater than the key in x. So in this side, it must be greater than x. Another property of the binary tree is that for binary search tree is that there should be no duplicate nodes. All the key values should be distinct. All the key will be different. So with this property, we will have some examples to show you. For example, okay, the key property is that smaller values in the left subtree and the larger values are in the right subtree. For example, this x. X must be greater than y and x must be smaller than z. So it is the binary search trees. So let's see these three examples. As you can see, these three examples, not all of them are binary tree. First, can you spot out which of them are binary trees? First, they are all binary trees, but not all of them are binary search trees. As mentioned previously, for the binary search trees, it has to obey the rules given here. And as mentioned here, all the keys are shown here. So let's see here. For every node, for these two trees, for all the keys, for those on the left must be less than its parent, just like this one. 25 is less than 30, 5 is less than 10, 2 is less than 5. For these three, 2 is less than 5, 30 is less than 45, and so on. And those on the right must be greater than that of its parent, just like 25 is greater than 10, 45 is greater than 5, 30 is greater than 10. So all the nodes obey the stated rules. However, this one, okay, the one on the right, you can spot two things to show that it is not a binary tree. Can you spot it? First, this 30 should be on the left of this 45, but it is on the right. Therefore, it is not obeying the binary search tree property. Second thing is that this 25 is on the left of 10. It is also violate the rule that all the nodes on the left of a node should be less than that node. Therefore, you can see that for this one, there are two ways to show that it is not a proper binary search tree. So let's see the for example 2. So remember that when you enter the value in a binary tree, it should have a sort of sequence, because the sequence of the nodes to be inserted in the tree will affect the shape of the tree. Okay, let's see this case. Okay, you can see the sequence is 20, 10, 6, 2, 8, 30, 15, 40, 30, 25. So let's see what is happening when these nodes are put one by one. Remember, all these are the keys. First, as mentioned, the first one is 20. And then when you put 10 here, it should be put in the left of 20. And if you put 6, okay, it's further put on the left. If you put 2, it's put on the left of 6. If you put 8, it should be the left of 20, left of 10, and right of 6. For 15, it should be the left of 20, but the right of 10. Further, if you put 40, okay, it should be right of 20. If you put 30, left of 40, and 25 should be right of 20, then left of 40, and left of 30. So it constructs the whole binary search tree.